Different cultures, for example, one of them is named Ba Rock. They form a huge structure called bernucles that surrounds the celestial body along the equator. The maculas are separated by high mountain ranges, and their surfaces are cut by deep fissures, hundreds of kilometers. The macula is located west of Tumbo Rio, is the largest dark spot on Pluto with a size of nearly 3,000 kilometers. Its surface reflects only a maximum of 30 pH. The light that falls on it creates a sharp contrast with the nearby bright and light Sputnik play. There is still no exact information about the nature of the maculas. It is thought that their dark color is due to the function. The high amount of thins combined with the relatively high density of impact craters suggests that the maculas are very ancient. The surface of Fulu macula is also not uniform. The western part has an undulating terrain. The central part is a smooth plain, and the eastern part is covered with mountains and impact craters, leaving the dark spot, Cthulhu macula. Let's face north. Here is the Low Rio, a large valley surrounding the north pole of Pluto. Surprisingly, this place is currently the most illuminated area on the surface of the celestial body. The reason is that Pluto's rotation axis is very tilted to the plane of the orbit, so in its motion, the North Pole is pointing towards the Sun. Pluto has some strange characteristics compared to other planets in the solar system. In addition to its orbit being significantly tilted to the plane of the ecliptic, the dwarf planet itself also constantly performs periodic oscillations near a certain point. This is due to the presence of a large satellite called Charon, which exerts a gravitational force on the dwarf planet. Mass Charon's mass is 1.52 nh10 to the 21st power kg, which is more than 11 pH. The mass of Pluto Charon and Pluto are tidally locked to each other, always facing the same side towards each other. Unlike Pluto, Charon's surface is darker and has a lot of water ice mixed with methane and nitrogen only in some areas. Apart from Charon, Pluto has a few other moons, but they are all much smaller and irregular in shape. Anx and Hira, discovered in 2005, are a few tens of kilometers in size, while Cabos and Stick, discovered later, are no more than 16 kilometers in diameter. All of these bodies are mostly made of water ice and may have been captured by Pluto's gravity from the Kuiper belt. Unfortunately, a large part of Charon is not in the view of the New Horizons probe's camera, but many interesting topographic features can still be found on its surface. For example, south of the equator, there is a large area called Assis Vulcan Planum, with an area of at least 400,000 kilometers, is equivalent to the average size of a country in Europe. The New Horizon probe is now more than 50 astronomical units away from Earth and occasionally sends back extremely important data until around 2030. All of its systems will gradually stop working and the probe will be alone in cold space. Did you know that every second, trillions of mysterious particles pass through your body without you knowing? But these particles are called neutrinos, or also known as ghost particles. They exist everywhere, but hardly interact with any matter. They can even easily pass through the Earth. Scientists estimate that a single neutrino can pass through 1,000 dense blocks of matter after traveling 1 light year. So how was this mysterious ghost-like particle discovered, and what role does it play in the universe? In 1914, British physicist Chadwick discovered that during beta decay, matter lost a part of its energy in an inexplicable way. Although this loss of energy was very small, it violated the law of conservation of energy that is the foundation of modern physics. Some people even began to doubt the accuracy of this law. It was not until 1930 that Austrian physicist Wolfgang Pauli proposed a bold hypothesis that during beta decay, in addition to creating electrons, a type of electrically neutral particle with no mass was released, carrying the lost energy. In 1932, physicist Enrico Fermi named this particle the neutrino. However, Because the interaction of neutrinos with matter is extremely weak, Pauli even thought that it would never be detected. After more than 20 years of effort, two American physicists, C and D, finally directly observed the neutrino in 1956 using a nuclear reactor. This discovery not only confirmed Paul's hypothesis, but also helped Rhines win the Nobel Prize. Nobel Prize in Physics in 1990. Today, we know that neutrinos exist everywhere in the universe. They are created from the Big Bang, supernova explosions, and nuclear fusion in stars. For example, the Sun is a giant neutrino factory. During nuclear fusion at the core of the Sun, 4 protons fuse into a helium nucleus, simultaneously releasing 2 positrons and 2 neutrinos. According to theoretical calculations, the Sun produces about 10 to the 38th power neutrinos per second, and about 60 billion solar neutrinos pass through each cubic centimeter of the Earth's surface per second. Although the interaction of neutrinos with matter is extremely weak, it is not impossible that for every 10,000 billion neutrinos passing through the Earth, one will collide with an atomic nucleus. In 1968, the American scientist Raymond Davis placed a 615-ton container of perchloroethylene solution 1,500 meters underground to detect solar neutrinos when the particle chlorine-37 nucleus is neutrinoized and touches. It will transform into argon-37 by monitoring the amount of argon. 30 scientists can indirectly detect neutrinos. However, the experimental results were surprising. The number of neutrinos detected was only 1/3 compared to the theoretical prediction. This is the famous mystery about the disappearance of solar neutrinos. It was not until 2001 that this mystery was solved. The experiment of the Super Cameo Candid detector in Japan discovered that neutrinos can change from one form to another during the propagation process. This phenomenon is called neutrino oscillation. This discovery not only explains the disappearance of solar neutrinos, but also